Good morning to everybody. So I'm going to give you a kind of a historical view of how the Apache Web Services stack has come about and how things have evolved over time and the current directions that we're taking. And of course, these are all open source projects. So as you know, anybody is free to come and contribute to them and help improve them in the direction that you think is right. So in terms of overview, I'm going to start by giving you a perspective of how the specs have evolved, because that has an impact on how the code has evolved as well, and kind of go through the evolution of the various specs that have been driving the implementations of the web services middleware. And then talk about the Apache stacks and how those have evolved, and just to give a quick understanding of where we are right now and what the current direction is and sort of what kind of stuff is being built now. Very briefly look at some of the alternative stacks out there and how we stack up against those things, and then wrap up. I should be done with enough time to have questions and answers. If you have questions, feel free to jump in though. I'm fine with that. Okay, so a small bit of history about how SOAP came about. So SOAP was originally started at Microsoft. It was a project that they started in the early 90s, or mid 90s really, to look at how to bring XML into the communication mediums that they were using. So instead of evolving DCE, they were looking at ways of bringing XML as the protocol to use, basically, as a message format to use. XML RPC, which is a widely used protocol now, was one of those things. It was done in that chain of evolution and kind of forked off and went public and took a life on its own. And it's very much a very simple RPC protocol done with XML as a message format. In 1999, there was a version of SOAP released publicly called SOAP version 0.9. And what that was basically was an RPC protocol, and it was very much tied to HTTP. And the problem with that being tied to HTTP was that they couldn't get traction in a wider community. So IBM kind of became part of the community in late 99. And then one of the major things that was done in the next version, somehow 1.0 got lost in the way, right? There was no 1.0, there was a 1.1. When 1.1 came out, 1.1 basically was designed to be completely agnostic with regards to transport. So HTTP was treated as a transport, and it doesn't matter which transport was on. Also, while RPC was supported, there was sort of a more of a messaging structure underneath. Yet, there was a core part of, there was a major component of the SOAP spec was something called the SOAP encoding data model. And what that was a way of serializing graph data into XML and recovering it on the other side. And that really fundamentally is inconsistent with treating with XML messages, because XML doesn't represent graphs naturally. Yes, you can represent graphs in it. And by doing that, you effectively brought the whole weight of RPC structure into the SOAP infrastructure, basically. And that was released in April of 2000. And then the spec was submitted to W3C, and there was a working group formed. Over a couple of years, SOAP 1.2 came out, and SOAP 1.2 basically is a purely messaging format. It just talks about how you take a simple message structure, take it over to the other side, and how the processing should work, and the semantics of the message exchange. And defines what are called message exchange patterns, which are ways in which you can have a one-way message or a request-response kind of pattern, or arbitrary patterns like that, basically. So it fundamentally went from being in fact, SOAP used to be an acronym until 1.2. SOAP stood for Simple Object Access Protocol, but it was dropped, and SOAP 1.2 is just SOAP. It's not Simple Object Access Protocol. And the way people explain it usually is that SOAP never had anything to do with object access. It was not a protocol. It was a message format, and it certainly was not simple. So it was really not a good acronym. So it was sort of a good time to drop it. And also, the entire graph stuff was completely taken out. And it's very much just a very straightforward thing. Yeah. It was Microsoft who came up with the acronym originally, and it was it was at a time when remember they're coming from a DCE legacy, right? So it was distributed object infrastructure, and internally it was impossible to say there are no more distributed objects. What we have now are messages. And as you probably know, in the distributed systems community, this is a long-running battle whether you need distributed object systems or you can just do with messages. And who's on top is always an ongoing historical battle. And in the web services world, that battle's been settled. Basically, there is no concept of distributed object anymore. It's very much just purely messages. So that's sort of how SOAP specs evolved over time to where we are. Now let's look at the other core component of the web services stack, WSDL. So WSDL started with, from the Microsoft side, with something called SDL, Service Description Language. It's sort of the inverse of the way WSDL is structured now. WSDL structure now is that there is a notion of an abstract interface, and then you bind that interface to some protocol and wire format and so forth as to how you're going to send the data. In SDL, it was the opposite. It was that there is a way of sending messages for HTTP, there's a way of sending messages for something else, and then you put it all together and said, this is a service. So sort of, it really wasn't a service description language, it was sort of a protocol description language. IBM, my group, we had an alternative proposal called NASL, Network Application Service Specification Language, which was very much like the current WSDL in terms of the abstract and concreteness, except it was all about RPC basically, right? And then when those two were merged, WSDL 1.0 was very much a merger of the two, which took the abstract and binding nature from NASL and combined with the more message-oriented structure that SDL had instead of the RPC structure. And we came up with this concept called message, which, how many of you know what WSDL is, by the way? Does everybody have a, most people know? A few people, okay. So WSDL stands for Web Service Description Language. It's a language that you use to describe what a service does, basically. Right? It's, so if you, it allows you to say, this service has this kind of message interactions, it takes this schema and produces that schema, simple stuff like that. And then tells you how you carry those messages back and forth, how you format the messages, what kind of headers you have to put, and so on. So in order to do that, WSDL, when these two things were merged, WSDL introduced this concept called message, which is a representation of all the things that are going from the source of the message to the destination. And it's really, the structure was that it was a collection of pieces of data that had to be sent or received. So it's sort of like, think of email, right? So an email message contains a main body and a bunch of attachments. So WSDL structure was that this is the collection. There's a collection of parts, and each part can be sent in certain ways. WSDL 1.1 came out a few months later. That's what was submitted to the W3C. It's pretty much industry standard. Everybody uses it. It's quite ugly. A lot of people hate it. You can blame me for most of it. But it works, basically, right? So it's not great, but it works. And it's widely used. Everybody supports it. Before we go on, let me kind of explain the design principles that drove WSDL. Was that the design model, we were in IBM. So from IBM's perspective, while all this XML, HTTP stuff is wonderful, there was no interest in losing JMS. There was no interest in losing IOP. There was no interest in losing any of the other mechanisms that IBM had for interacting between different components of a distributed system. So the design point was to say, what we need is an abstract way of describing what a service does, and then concrete ways of binding them into various forms. So WSDL was designed with that idea in mind. So the abstract description of WSDL, even though it uses XML schema to describe the data that goes back and forth, in fact, the data doesn't even have to be XML at all. It's just an abstraction saying, XML schema lets you describe a data model, and that's it. How that data model translates onto the wire, whether it's in XML or whether it's in an IOP call, an in-memory call, was a separate thing, basically. And this was implemented. This was not some random thing. We created something called WSIF, Web Service Invocation Framework, and it was open sourced to Apache after a while. What that does basically is provide a single programming model that works at the abstract level of WSDL, and then lets you plug in different bindings. So in fact, IBM uses this very heavily in various products, the workflow products and a bunch of other places. And what it's used to is to allow somebody to conceptually program and design compositions using web services, but yet underneath what you have are possibly SOAP HTTP services, maybe it's an XML message going over JMS, or maybe it's an IOP RMI call, basically. Okay, and so on. So and in fact, we even had a COBOL binding. Somebody did a COBOL binding, so you could make a COBOL copybook and invoke mainframe activities as part of a service invocation, basically. So that's really what motivated this abstract, concrete design. So the idea was that web services are an abstraction, not a concrete XML, HTTP thing, but an abstraction that can be realized in various forms. And that's the same principle that you see when people talk about service-oriented architecture today. You talk about service-oriented architecture as an approach, and web services as a realization of that architectural model. right? And that's the same principle that you see here. Well, the question is, does it really work? And how far can you take it? So the idea was that if you design completely abstractly, then you can bind them to various forms. So think of like security. The original idea was that I should be able to say this service requires authentication. And maybe the authentication happens over symmetric SSL, or maybe it happens over WS security, or maybe it happens over some RMI IOP security context flowing through, right? And those are all authentication conceptually. But in practice, that's not the way the standards evolved. While IBM had that mindset, it was impossible to get Microsoft, who had the exact opposite mindset, which was that the world is completely about XML, the world is completely about HTTP, to buy into this stuff at all. So what ended up happening was that the other quality of service specs that were defined, like WS security, reliable messaging, addressing, all of them basically only work for SOAP. Right? If you look at WS addressing, it defines a bunch of SOAP headers saying this is how you set the target and the fault address and the reply address for a service invocation. If you look at reliable messaging, it tells you how you reliably send a SOAP message back and forth, and so on. So what that does is it basically makes it so that the WSIF stuff works as long as you don't have any of these additional qualities of service. Right? So if you want to do sort of lightweight service invocation, which doesn't have any kind of extra security, any kind of extra reliability, then you don't have a problem. But if you want something deeper, then the model doesn't work. So the conclusion you derive from is that really you cannot make web services work completely transparently across all different protocols. So even right now, IBM still positions web services as something that can do that, but in practice, you really can't do that anymore. The reality is that if you want to do web services and you want to take advantage of things like message level security that WS security gives you, and not depend only on transport level security, then you have to buy into this stuff. There's no other way around it. Okay, so that's sort of that gives you an idea of how we went from having this WSDL-centric view of web services to going back to saying, well, really, it cannot be made to work, because if you try to push it too hard, it doesn't hold up, and then you have to go back to saying it's more about SOAP. So there's a new version of WSDL coming out called WSDL 2.0. Yes? Right, so same thing. So I actually, let me answer it a little bit, and then I have some slides about that. So REST, or let's just look at sort of XML over HTTP, right, without SOAP. The difference basically is that if you don't, the value of SOAP comes in if you have something beyond the message that you need to send. So if I want to sign a part of the message, right, I can't do that with REST. I need some additional envelope structure to say this is the message and this is my signature, right? I have to keep that somewhere else. And if you don't have any of that stuff, REST is good enough. You don't need anything else. So as you go forward, you'll see in Axis2, that's the model we support. So the programming model is purely at the message payload level, basically. Whether you need web services or not, it's a question of the kind of qualities of service you need, right? We'll come back to that in a bit. WSDL 2.0 is a new version of the spec that's kind of fundamentally different from WSDL 1.1. It's the W3C version. It's basically done now. It's going through interop testing. The fundamental difference is that it has eliminated the message concept and gone to saying, well, actually the thing that matters is it's replaced the message with an XML element. So it uses an XML element as the abstract description of an entire message. Now, in order to make this work, you have to deal with first of all, this makes a common case of sending a bit of XML back and forth extremely simple to describe, because it just says, this particular message exchange has this XML element going in, this XML element coming out. And if you want to send it over HTTP, it just says drop the XML as the body of the payload of a post, and you get that in the response, and that's it. So you don't have to say anything, it just sort of works. Same thing for SOAP. With a simple SOAP binding, it just means take the XML element, drop it inside the SOAP body, right? And on the response the other way around, it's inside the SOAP body. In order to make this work, though, you need one other bit of information, which is that XML has this issue that you cannot have non-XML content in the middle of an XML document. So XML element as the abstraction of a message works nicely as long as the whole world is XML. But often you want to be able to send an image, for example, right? You want to attach an image as part of the message and send it somewhere else. In order to do that, the only solution in XML is to represent it as as base64 and embed it in the middle of the XML document. Now, of course, base64 is inefficient to do that. So to solve that, there was something called XOP and MTOM that was created. So let me explain what those are. XOP stands for, these are W3C standards, by the way. XOP stands for XML optimized packaging, which basically addresses the problem of having non-XML stuff in XML using a trick in the XML info set. So XML info set is the information model of XML. That means it's the abstract description of what an XML document represents, basically. Now, it turns out the restriction that you cannot have binary characters in the middle of an XML document is a restriction in the XML serialization. That is, if you look at the angle brackets, right? XML means the angle brackets. XML info set means a tree data model that represents what the angle brackets contain. And at the tree data model level, there's absolutely nothing which constrains you from having any kind of characters in a node of the tree, right? So what XML optimized packaging does is basically use that approach to say, look, at the abstract level, at the data model level, there is no problem. You can have non-XML stuff. Okay, and then when you want to put it back down to the wire and print it out as XML characters with angle brackets, then you have a problem because you cannot put it out there because it doesn't allow you to put it. So if you take an info set that has non-XML characters in it, when you serialize it into XML, you have to put it out with base64 stuff. Okay, and then, well, of course, the problem with base64 is it's inefficient. You get 33% overhead and so on. So there was another spec introduced called message transmission optimization mechanism, which uses MIME basically to say if you have a XML document which has these binary info set items in it, and if you want to serialize it, if you have the option of going into MIME, that binary attachment becomes a MIME part, MIME attachment, and then that element gets replaced with a reference to that MIME part, right? So if you're going over a transport that sends MIME in binary like HTTP, that works great. Right? If you're doing it over SMTP, it doesn't do anything because the MIME becomes base64 again anyway. Right? So it works nicely for HTTP to deal with the non-XML content in an XML document. So really, that's what makes it work. That's what allows WSDL 2.0 to say the entire message that we are sending is a single XML element, and now I can package it all together and send it out. So what does that mean? What this means is that the concept of attachment is no longer a problem, and they are essentially built into XML, WSDL, and SOAP, right? And that's really important because what that does is earlier, if you go back to the SOAP 1.1 world and SOAP with attachments, which was a spec that described how you send attachments, if you want to digitally sign the message that's going, you couldn't sign the attachment. If you want to sign the attachment, you had to use SMIME, basically, right? There was no single security model that covered both. With this approach, because logically the attachment is part of the same information model, what you sign is that extended info set, basically. And then when you sign that one and put the signature as a SOAP header, when you serialize it, to send the message over there, you might end up taking that binary content, putting it as base64, or take the binary content, sticking it as an attachment. But it doesn't matter. It ends up on the other side, when you recover it, you get the same model back, check the signature, and it works. Right? So this makes it basically that the concept of attachment has essentially gone away. It's now part of the data model of the message, and it's very easy to manage that, and it works completely consistent. Yeah. Yes, so there are a couple. So first of all, you can also do the same thing for REST, right? So the same, because these are an XML level, so it really nothing to do with SOAP, right? So you can do it for REST, which is the same thing. Or there's a whole bunch of binary serialization that people have defined, which essentially, instead of using MIME, just sticks the binary info set in the middle of it. So, right? So binary serialization is a non-standard approach yet. So if we are talking to each other and we're using binary serialization, we're essentially using a private protocol. There is a working group that's defining a binary serialization. It's not done yet. It's going to take a couple of more years. So web services is not just about the SOAP level. There's a whole bunch of stuff that's being built on top of it. So let me kind of explain. I'm not going to go through all these specs. I'm just going to give you a little bit of understanding of what they are and why they exist. So web services messages are are basically SOAP envelopes that you send back and forth. And they can be carried over all kinds of transports, HTTP, SMTP, XMPP, whatever. There's no restriction on what you can carry it over. WS addressing essentially plays the role that the message headers do in an email message. If you look at an email message, the message headers, there's a set of standard message headers, like from, to, subject, reply to, and so forth, right? This is all standard, is part of RFC 822, basically saying this is the headers that must be there. SOAP didn't define those headers. WS addressing defines those headers. Those are essentially SOAP headers saying this is where the message is coming from, this is where the message is going to, this is the subject of the message, and so on. Then on top of this base infrastructure, there are three broad categories of features that have been built. One for security, one for reliability, the other one for transactions. So for security, there is something called WS security, which uses the spec called XML security and extend it to fit it on top of SOAP to be able to encrypt and sign XML messages, SOAP messages, basically. So you can sign a part of it, you can encrypt a part of it, and do all kinds of stuff like that. And then that's basically public key encryption. There's something called WS Secure Conversation, which does what SSL does, basically, which is instead of doing public key every single time, we establish a context and then drop down to a more efficient encryption mechanism. And then there's something called WS Trust, which is sort of like Kerberos. So you have a trust server, you can you go authenticate with it, both parties trust it, and you can send the ticket over to the other side, it authenticates, and the message goes through. So it's essentially a full security stack available on this infrastructure. Reliability, there's something called WS Reliable Messaging, which implements a protocol that guarantees delivery. So there are different kinds of delivery assurances. So you can have one saying, if I send a message from A to B, it should be sent exactly once and in order. And then there are certain protocol messages that go back and forth to make sure that the message actually gets delivered once and delivered in order to the other side. Then there's a set of transactional protocols that have been defined: atomic transaction and business agreement. Atomic transaction is basically a two-phase commit, and it's not something people will do over a wide area network. It's used primarily to carry a transaction between a .NET platform and a J2E platform, for example. Right? If you want to move a transaction between the two of them, this is a way of doing it. There's something called business activity, which is a loose coupled transaction model. It's essentially a coordination protocol that lets you have many parties that are involved with some sort of distributed wide area interaction be able to coordinate and come to a single agreement on the activity. Now, on the metadata side, WSDL solves a problem of basic service description. It tells you, this is the format of the message that I'm going to send you, this is the format of the message you must send me. What it doesn't tell you is, if you're coming from Microsoft, your messages must be signed and must be using this kind of algorithm, or so there are no policies, basically. So there's another spec called WS policy, which is a framework for how you will assert into each message, into each interaction, what the business protocol must be, right? Whether you must send those reliably, whether you're in the middle of a transaction, whether the transaction is required, whether it's optional, all of this kind of stuff. So essentially, so this is similar to what, if you look at J2E and look at the policies that are in there, it's sort of similar to that in terms of what you get out of it. Business process execution language is a service composition and workflow language. What that allows you to do is to say, there's a service here and there's another service here. I'm going to put them together and create a new service and publish a new service. So it allows me to compose a set of services and to publish new services, basically. And metadata exchange is a way of querying an endpoint and saying, what do you have? What are your policies? What is your service description? And things like that. So taken together, all of this stuff lets you essentially do anything that you do with the current enterprise middleware, basically. So if you look at what J2E does, or you look at what .NET infrastructure does, there's enough stuff in here to cover all of that functionality. Now, do you always need this? Absolutely not, right? If you're doing something over the web and the other end is a consumer application, you don't need any of this stuff. But if you need a more reliable interaction, if you want it to be secured at a higher level of granularity than just saying transport level security, send it over SSL, then you need to have some infrastructure saying, I need to be able to sign a message and hang on to the signature and send that off with the message. When you get to that level, you absolutely need either SOAP or something like SOAP, because you need to have some envelope structure to say this is the message and this is the signature. Right? That's essentially where SOAP comes in. There is a ongoing battle in the world about REST versus web services. It's interesting that within enterprise structures, this battle doesn't appear to be there because people are sort of settled on saying, I need all this extra overhead that in order for me to get reliability and transactions and security and so forth. So first of all, REST is not something new. REST is what is the underlying structure of the web. and it's been around for 15 years, and it's working really well, of course. What web services, the WS star stack does is define a set of protocols using the web as a medium of communication, not exploiting all of the web, but using sort of part of the web to allow people to communicate with these additional qualities of service. So in my mind, the battle of REST versus web services is the wrong one, because they're solving different problems. The use of web services is to create what are called service-oriented architectures, where the design point is that there are services, and I'm going to invoke services and go discover services and so on. The web is not a service-oriented platform. The web is a resource-oriented platform. In the web, there are no services, there are resources. Now, I'm sort of looking at the pure web, right? When you take web with cookies and web with queries that go in with gets and so forth, it's a little bit fuzzy because it's not really what the web is supposed to be in theory. In a resource-oriented architecture, you can build distributed systems with either of these approaches. If you build one with a resource-oriented architecture, what you end up with, what you have to implement, the design is fundamentally different from what you end up with as a service-oriented architecture. And so the reality is that there is this sort of battle saying one is better than the other, and it's really an unnecessary battle because it's not that one is better than the other. Depending on the kind of system that you're trying to build, resource-oriented architecture is a better model, and for other things, service-oriented architecture is a better model. The web itself, which is essentially an information distribution system, resource orientation works absolutely well. But for certain other kinds of integration scenarios where you're talking from one program to another program, that's not necessarily the one that works very well. So there's sort of this is an ongoing battle, but it's something that in the next few years we'll get I think more clarity on when one should be using one style versus the other style. There's another aspect of this battle which is interesting, which is the idea of plain old XML versus SOAP, which is a question that you were asking earlier. The question is, when do you need SOAP, basically, is the bottom line question. If you look at SOAP, SOAP is basically an envelope structure which says there's an element called header which contains any number of XML elements which are header elements, an element called body which contains one special element, which is the body. And that's pretty much it. And there's some rules about how you process the headers and stuff like that. But basic SOAP is pretty much that. So if there are no headers, SOAP gives you absolutely nothing other than two element wrappers, right? So if the message you're sending basically doesn't have any SOAP headers, then the SOAP envelope is exactly the same as taking the XML payload that you want to send, wrapping it twice, and sending it over there, right? So it gives you nothing at that point. So the point is, if you don't need any of the other qualities of service that you get by using SOAP, such as the ability to sign a message, or such as the ability to use reliability to deliver the message, using SOAP doesn't buy you anything. And that's really what WSDL 2.0 design point has been to say, the thing that matters in a message is the payload, is the XML information that you're trying to send. So that's why in the WSDL 2.0 description, the body is this XML basically, is the thing that you're describing as the data that you're sending is the payload, just that XML bit. Okay? And I'm pointing this out because this is sort of the design point of Axis2 as well. Axis2 design point is very much that the thing that matters is this payload. Whether you carry it over SOAP, whether you carry it over a plain old XML, doesn't really matter from the programming model perspective, and I'll get back to that in a second. Right? So this is another one of these religious battles that happen on the web in the blog sphere, saying, REST is POX is the right solution, no, SOAP is the right solution, and the answer is neither is the right solution. Depends on what you want. If you don't need anything beyond just sending the payload XML, you don't need SOAP. It doesn't buy you anything at all at that point. Right? It buys you something when you have something extra to send. WSDL 2.0 defines a very nice GDP binding. If you haven't looked at that, it's certainly interesting. What it defines is basically how you take an abstract XML schema and map it into a URI to do a get. So it basically takes the child elements of the schema and makes them into either path elements or query parameters. Or it can map it into a post where part of it goes into the URL, part of it goes into the payload, and same thing for put and delete. So what this allows basically is to support POX bindings over HTTP very nicely. So essentially you can describe any web form using WSDL 2.0 and say this is the data model that needs to be sent, and here's how it should be sent over there. It should be this part goes in as part of a path information, path item in the URL, part of it is a query parameter, and part of it is payload. Right? It doesn't deal with, right now it doesn't deal with the attachment stuff, but actually with a very small extension which we're working on, we will be able to deal with that. So essentially you can have a XML message which has an attachment, then when you do it over plain old XML binding, you'll do a post and you'll have a MIME part, basically, yes.
What is the stuff about serializing and deserializing data types?
It doesn't exist in the web service specs, that's the whole point. That's a flaw of the software. I'll get back to that, it's an excellent question. Right? That's my next topic, is sort of the evolution of the software with this evolution of thinking. Now, again, going back, I'm one of the people who started this stuff. So I wrote the first SOAP stack. At that point, it was all about taking Java and serializing in and out of XML. Axis 1 very much followed that, and that's 2001, 2002 timeframe. Every web service stack done at that timeframe was done like that. Right? The new stuff is very, very different. So let's look at sort of the history of Apache web services stuff. Apache SOAP was the first SOAP implementation. We did it basically while doing the spec as an implementation to prove and to make sure everything was working right, and it was released right with the spec. And essentially, it took the model that the way you implement a web service by writing a Java class, and that's been an amazing mistake because to date everybody implements a service by writing a single Java class, and really that or a class in whatever language. And that's completely, there's a complete disconnect between those two things. The life cycle of a class, the life cycle of a service have nothing whatsoever to do with each other. There's no concept of instance in a service. So there's so much of disconnect between what a object-oriented implementation methodology is and a service implementation is. And unfortunately, going back to the original implementation, because it was done that way, basically every implementation has followed that model, and now everybody expects that if you don't have a switch to drop a Java class and make it into a web service, then your stack doesn't work, because that's how it should be, basically. And it's really not. And the reason it shouldn't be because is that web services are not about synchronous invocation and getting a response back with a blocking thing, right? Java classes are fundamentally, in any object-oriented language, a method invocation is a synchronous method call. And it's not a model where you have some message going into some running system, it does something, maybe sometime later it'll send a message back, and so on. So that's really been a bit of a mess right from the beginning. Apache SOAP only dealt with the SOAP body. It ignored basically everything else. It was very much a quick implementation, and it's still used in production by various people, unfortunately. Apache Axis was about a year and a half later. We decided to rewrite it because it didn't deal with headers. There was no convenient way to write handlers that let you play around with various headers. And this is when different protocols like reliable messaging was starting to come out. So we came up with this concept of handlers, which is now pretty much standard. The .NET infrastructure has it, all the JAX WS, JAX RPC, all these guys have it. And it switched from DOM to SAX to get slightly better performance. And Axis 2 was extremely widely used, and it's still widely used. It's pretty much in every application server in various forms. Some of the key characteristics of Axis 2, the core of the system had the mindset that the XML has to be converted to Java. So in the guts of the system, there is this concept of data mapping, basically, of a type mapping going from XML types into Java types and having the ability to convert that before getting out of the system. All right? And also it assumes a synchronous request response model. That is, the execution path was you get a message coming in, something happens, message goes out. Right? It was always this request response pattern. And again, now if you understand the specs, you know that's not the case. It's really, there is no such concept at the message level. It's just one-way messages. So Axis 2 was something we started in 2004 and essentially kind of broke all of those fundamental models and says, the thing that matters is really just the XML. There is no concept of data binding at all in the web service stack. And what you need is a one-way message processor. So it's simply an XML pipeline. So you get a message coming in one way or the other, and it lets you put filters to mess around with the headers or whatever you want in the middle, and then the message gets delivered to the application and it's done. Right? And because the programming model is dealing only at the payload, it natively supports both POX and SOAP by design. Because all it cares is basically at the payload. It gives a payload to the application. Yes, there's some context. If you want to find out whether there were headers, whether you were in the middle of a SOAP envelope, or just POX, you can figure that out. The way it's built is using something called Axiom, Axis Object Model. So what we do is the following. When a message comes in, we create, so everything is built using stacks. There's something called Streaming API for XML, and that's a Java API, and there's a similar one we've written for C. So it's a pull API basically for reading XML. So when a message comes in, we start reading the envelope and read off enough to get the headers. Now, if it was a POX message, right, plain old XML message, there are no headers basically. And then you don't read the rest of the stuff. So you build, using the bit that you've read, you build an XML information model, and you create, essentially you leave it unfilled, right? So it's a deferred built model, and then pass it through. And then once it's built, and then the header processing happens. So if there's a reliable messaging stuff, it might do something with it. If there's security, it might read the rest of the message, and so on. And eventually it goes out the end and gets to the application. At that point, you can go and say, actually, I want to now read the underlying pull stream, pull the thing, and if the tree hasn't yet been built, it's going to be pulling right off the stream, basically, right? So it's a pull-through deferred built model, okay? And what that allows you to do is you get very high performance because you don't have to build the XML information model and then pass it on to the application. Because many applications do still want to do data binding, but we do it outside of the core of the engine. So we do support it because programmers want it, but it's done outside the core. So when you do data binding, what we do is we don't take the hit of generating an XML model and then converting it out to a Java model, right? We keep it in the stream and then pull it right through into the application. So basically, you build it up to the point of the end of the header because we process all the headers. That sort of rules of SOAP processing. You have to do that, and then whatever the data that's there, we just give it to the application, and it just pulls it through the way it wants to pull it. So the runtime model of Axis2 is that a message comes through in some kind of a transport listener. It could be HTTP, it could be XMPP, it could be whatever you want, and then it gets mapped to something called a message context, which contains in it a logical SOAP info set. Now, I say logical because the way we represent a message in the system in Axis2 is always a SOAP info set, whether it's a plain old XML message or whether it's a JSON representation or whatever. So we map everything into a SOAP info set. Now, in some cases, it's a fictitious SOAP info set because there was no SOAP at all. It was just a plain old XML message. But we do this so that every handler can perform the same way. Everybody gets the same data model in the rest of the chain, basically. And then the real data might have been a plain old XML thing or might have been a JSON representation, and so on. And then once the message has been brought into this structure, the engine applies whatever the policy handlers that have been there. Maybe there was security, maybe there was some transaction policy, whatever that's basically. And then message gets delivered to something called a message receiver, which is at the point at which we get out of the engine, we context switch to user code. And then it does whatever it wants. So the concept of data binding is not in the core, but yet we have to support it because programmers don't want to deal with XML. And the primary reason for that is dealing with XML in Java especially is absolutely crappy. The Java APIs for XML really are nice to work with. If you're familiar with E4X, E4X has a much nicer model, and PHP, for example, has a nicer model, and so on. So what we've done is basically, once you get to the message receiver, when you're out of the system, if the user wants it data bound, then we will at that point map it from the XML infrastructure into a Java class, whatever they have asked us to do, and then hand it over to the application. And typically, this code is actually generated at development time using the schemas that you have in hand, right? So that makes it very efficient. There's no reflection involved at all in executing it. So we support different kinds of service implementation types. That is, the actual logic that the person writes can be written as a POJO, just as a regular Java class. Can be written as a Spring description that gets executed within a Spring context so that you can pump it onto the appropriate bean that you describe. Can be generated classes that we've generated for you, or it can be stuff that directly deals with the XML, which is sort of our preferred way because it's the most efficient, it's the most direct route. But it takes a little bit more work because XML programming in Java is a pain, basically. And then you can do whatever you want. So for example, if you tie this into a BPEL process, a workflow process, you would take that XML message and pump it right into the workflow engine as an XML document, because that's what it's going to be dealing with and navigate with XPath and so forth. Now, on top of this core, we have a set of modules that we've written. The modules are extensions of the core system, which implement various handlers. Remember I said there are these handlers that you drop in? Now, what these handlers do is implement various protocols. So we have implementations of security, secure conversation, trust, all of these things, basically. And these are just add-on modules. So you have the Axis2 system, and these get packaged as something called a MAR, a module archive. And once you drop that in, it picks it up, and it inserts handlers into the execution chain at the right place. So there's a small constraint language saying which handlers go in front, which handlers go after relative to the others, and so on. And then the execution chain gets set up and messages come through, they get pumped through that and executed and dropped at the other end to the message receiver. Now, we are not implementing this stuff only in C, we're also doing only in Java rather, we're also doing a C implementation. It's exactly the same architecture. We started this a little bit later, and if you guys write in C, you know that it's a little bit more work to write in C, so it's lagging a bit behind in functionality. But it's very carefully designed to be highly embeddable. So we are working on embeddings into PHP, Perl, Python, Ruby, Firefox, IE, and also meant for different devices. So let me tie this back a little bit into what I do. So the company that I set up, WSO2, is the one who's driving most of this work. They're all Apache open source projects, so they're not our projects by any means, but we are the ones who contribute to most of the projects in most amount of work, basically. So the thing we do in WSO2 is take these Apache components and kind of tie them all together into a product form. And the reason you need to do that is because Axis2 is a separate project, Sandesh is a separate project, Rampart is a separate project. So if you want to do it yourself, you have to download all these different bits, get the right versions that work with each other, and sync them up. So that's what the web services framework that we put out is, basically a packaging of all of that stuff, as well as language bindings. So we already released a first version of the PHP binding. We have an extension that extends the we have an XPI that extends the JavaScript programming model for Ajax with full web service capability, and we're working on the same thing for IE. We have something called WS Client we're doing, which is essentially, if you're familiar with wget in Linux, it's like wget, except that it can do full web service invocation, and it's just a command line script, basically, a command line program that you run on the shell. And we're doing a Swig binding, and through that we expect to do Perl and also Ruby and so forth. So Axis2 is really only the beginning of this stack of web service stuff that we're trying to build. It's the core of essentially what becomes an application server. The Axis2 engine becomes the guts of an application server. So we have something called a WSO2 web service application server, which is a packaging that takes Axis2 in the guts, in the core, and then wraps a runtime environment so that you can open up different listeners and send messages to it, and it runs as a server, basically. Right? So it's an alternative to a J2E application server. We're also working on other products on top of that, something called Synapse, which is an ESB. Basically, Synapse is something that allows you to take messages that are flowing between two parties, stick its nose in the middle, pull the message out, reroute it, do some transformations, and do whatever logging and management stuff that you want to do. So it's essentially a small rule-based language that you write in Synapse saying, this is what I want to do, the messages flowing through, and it pulls them out, executes the rules, and then passes the message through. Axis2, now I only talked about XML messages and XML protocols. So now let me tie it back to the WSIF stuff that I mentioned about multi-protocol stuff. In fact, Axis2 can deal with that because what WSIF depended on was the WSDL 1.1 data model of a message, and it had something called WSIF message which represented that. Axis2 runs on the WSDL 2.0 data model, which is that a message is an XML element. And because of ZOP and MTOM, the XOP and MTOM stuff, you can actually bring any kind of data model into that and make it work very efficiently. So it is possible to bind Axis2 to all the WSIF protocols. I have a grad student who's doing a master's with me who's actually done that. We are just in the process of getting the code out into Axis2 right now. Okay, so let me just wrap up quickly by mentioning a couple of our competition. There are other SOAP stacks out there. There's something called Xfire, which is quite popular. It's a very nice SOAP engine, but it's really very Java-centric. It's designed primarily for the problem that take XML, map it into Java, execute a bit of Java code. And if that's the problem you want to solve, it's a wonderful, lightweight system, but it doesn't really deal cleanly with other web service protocols. It really cannot be made to work properly like that. And the project has been dead-ended. It's been combined with something called Celtix to form this new project called CXF, which is currently under incubation. And what CXF does is basically, it's quite different from Xfire. CXF's data model is that the world consists of either XML or some other stuff and so on. So the message model is, in Axis2, it's completely an XML data model. In CXF, there is a sort of a union of things that you could have there. If you're familiar with something called JBI, Java Business Integration, this is sort of like JBI, but an improved version of JBI model, basically. It still uses DOM for the XML infoset model, and doesn't. And when it comes to attachments, they don't have a model that sort of represents attachments as part of the information model. So they kind of drop down and bring it back out, basically. They follow a lot of stuff that we've done in Axis2, so we consider that a form of flattery at this point. And it's fairly new, so it's hard to compare performance at this point because they're not done yet. Okay, let me wrap up. I apologize for running a bit late here. So fundamentally, the thinking behind web services, when we started this stuff, was very much web services all about XML, all about doing RPC calls over XML. And that they were all about being at a WSDL level, which is at this abstract description that you could bind to RMI calls, to Java method calls, to XML calls, basically. But that has changed over time, as hopefully you saw by the evolution of the specs and the implementations. Now the thinking very much is that web services are basically about carrying XML messages from one place to another place, and how they, and then anything else gets mapped onto that abstraction, not something else, basically. So that's essentially what Axis2 is doing, kind of rethinking the whole stack along those lines. So what we are implementing is a very XML-centric processing architecture in Java and C, with both meant to be plugged into all kinds of different languages, and we're certainly doing that, and we would welcome help in doing that for more languages. Right now, it's pretty much a faster SOAP engine, and there's a hell of a lot of performance left. We've only done very little bit of tuning. We know so many different ways in which we can make it better, perform better, including with optimized parsers that are SOAP aware and can deal with it much more. Our intention is to bring the Axis2 stack to perform at the same level or better that Java RMI performs, so that the use of web services versus not, performance gets taken out of that angle, right? It becomes other decisions, not performance. And we certainly believe we can do that. And with the C one, we expect to be able to beat pretty much anything, because there's absolutely no reason why the C implementation doesn't perform as fast as any C-based message model. Okay, I think I'm done. Thank you very much. If there are any other questions, I'll be happy to take it. All right, thank you very much.